Okay, so for this first one, A, B, and C, if you look at -2, there's nothing happening. So the limit is just the y value at -2. And the y value at -2 just happens to be -2. So A, B, and C are all -2. Then we get to D. D is asking us to look where in the graph? -4. What kind of discontinuity do we have at -4? A jump. Jumps do not have limits because they're not connected. Okay, if the left side and the right side are not in agreement, then at that place, it does not exist. So anytime you see a jump or an infinite, it is D and E. So D is D and E because we're looking at -4. But now when we go, I think the last one says +3, which is right here. I'm talking about the graph. The graph, see if this is my graph. The graph is connected. This is not a jump. What do we call this discontinuity?
Removable.
Removables have a limit. The limit is where the graph is. And the graph is at -2. So I need to make sure you understand this. If the test or skills check asks you to find f of 3, what would you say? F of 3 would be what? -3. All right, quick questions because we lost a lot of time and we got a lot to cover.
No.
Wait. Shh, can you whisper?
So it's like F and like that. It's you're finding the Y and the close on the close point, and then.
Are you talking about for this one that I just made up?
Yeah.
Yes.
And then like for the one that's always the open.
That's the graph. It's the graph. All right, let's quickly go through the next one. So for +2 right here, we have a removable. Removables have a limit. So the answer to A, B, and C is where is the graph? So where is the graph for A, B, and C? 2. If it said what is f of 2, then that would be 1. But the graph at 2 is at 2. D and E, at -4, we have another removable. Removables have a limit. Where is the graph? Not the point, but the graph. 0. And then E is asking at 5, which doesn't have anything happening. So where is the graph? -1. All right, so now that's the end of limits. So now we're going to move into 4.1. 4.1, that's homework 11. That is due on Tuesday, September 24th. We're going to finish it. We're going to work through it today and tomorrow. And then on Monday, we're going to start 4.2. So again, all this information, I just cut it from Canvas. It can be found on Canvas also. So now you can glue down the handout because I didn't want to wait for you to copy all this down. I just thought it would be easier for you to just glue it down. So go ahead and glue it down. The first couple questions in homework 11 is, what is a polynomial? The definition of polynomial. That's what I had you all glue down. So the two things that we're looking for is we can't have a variable in the denominator or a negative exponent. Having a variable in the denominator is the same thing as having a negative exponent. So that's the first thing we're going to look for. That would be a no. The second thing we're looking for is an exponent that is a fraction. Having an exponent that is a fraction is the same as having a variable under a radical. So what I want you to do is look at these examples that you have and just write yes or no. Which one would you say is yes? So if you see either one of these, the answer is no. So looking at these 6, I'm going to give you 60 seconds to just write yes or no. Yes.
You said, what is it, 4 point what?
We're in 4.1. Yeah. I think when you took a picture of the screen, it's...
Well, it got cut off.
Oh, it's 4.1 polynomial functions. I think that's what it's called, yeah. All right, so real quick, 60 seconds, yes or no. And then I'll give you the answers and we can see if we agree.
What does it mean like a variable under radical?
Yeah, like a radical is a square root, yeah. So I had 3 no's and 3 yeses. Who had 3 no's and 3 yeses? All right, go ahead and check your answers. The first one is a yes. The second one is a no because this x is under a radical. A square root is the same thing as a radical. The first one, you have a variable that has an exponent. If you have x to the power of 1/3, that's the same thing as saying the cube root of x. And then for this one, we have an x in our denominator.
So x is in the denominator, fraction is okay?
Yes, you can have a fraction, but you can't have a variable. Let's highlight that in the definition. A variable in the denominator is not okay. So if you look at this one, we have a denominator, but it's not a variable. It's a number. That's okay. But this is not okay. Make sense?
Yeah.
Pretty simple. I don't know how to make it complicated. I mean, it's just a basic definition. That's the first couple questions in homework 11. You have to look at equations and simply say yes or no. The second thing, and you don't have to write this down, just look at it. There's 2 different ways to write an equation. If I ask you to write it in standard form, that means it's all multiplied, no parentheses. But if it's in factored form, we're going to leave it in parentheses. There are some equations on the test, quiz, whatever you want to call it, where it's going to say in the directions, write the equation in standard form. Sometimes it'll say leave it in factor form. Factor form is by far the easiest way, but we're going to do a little bit of both in 4.1. So, next cutout in behavior. Wait, let me say something real quick though. Yeah. All right, so the next thing we're going to talk about is in behavior, which you might remember from algebra. We're actually doing that in integrated right now. In behavior. So go ahead and glue this down. I'll pass these out.
Okay, I get you 5 out of 6 times.
Yep, go ahead and glue this one down. In behavior. Did I miss anybody? Did everybody get theirs?
You on your own. Okay, that's one of me. That's one of me.
So in behavior is basically, and also if you look here, I have it the same thing I have here because we're talking about this in my integrated class, but what does the graph do on the end? That's based off two things. If you have a graph that has an even power, that means that the ends are going to be the same. So if you have the highest exponent is a 2, a 4, a 6, a 8, a 10, the ends will be the same.
Because they're even.
Because it's even. So even is the same. Now, if this is positive, this is what we call a positive leading coefficient. And it's even, both arrows will go up. If it's negative, then both arrows will go down. For an odd function, that's a little tricky because odd, the ends do opposite things. So when it's odd, they do opposite things. We're going to depend on this number right here. This number right here controls the right side. So if this is positive, that means the right side is going to go up towards positive. And the left side is going to do the opposite. But if we start off with a negative, that means that the right side is going to go down and the left side is going to do the opposite. When you look at this notation at the bottom, because this is how you're going to write your end behavior statements, when it says x approaches negative infinity, what side of the x-axis, or not x-axis, what side of the y-axis is your x value negative? On the left. So this is asking you for the left arrow. So the first row in each one is asking for the left arrow. Because it's saying when x is negative, what is y doing? The second one, where it says when x approaches positive infinity, that's the right side. So we're going to just practice doing a couple of end behavior statements as a short introduction, and then let's get started. So go ahead and copy down these two equations, and we're going to write our end behavior for these two. So again, we're just writing our end behavior. So our first one says negative x to the fourth plus 3x squared plus 3x. And then number 2, f of x equals x cubed minus 2x squared minus 2.
Okay. Is the degree even?
Just ask her what she said.
No, just making sure.
So there's 2 questions, and even though these equations are super long, the only thing that you're focusing on is the highest term. These terms don't matter. The highest term is like the big joker. It tells the ends what to do. So I'm only looking at negative x to the fourth when I answer the questions. For the second one, I'm only looking at positive x cubed when I answer my questions. So that's something to kind of keep in mind there. So really, you just need to write the first term. So for this first one, my highest power is 4, which is an even number. So because it's even, I know my end behavior is going to be the same. Is that the number in front? Is it a positive number or a negative number? Negative number. So I know that I have a graph where both sides are going to go down. So when I write my end behavior, you can only do this for even. As x approaches positive and negative infinity, f of x is going to go down. So we would say it approaches negative infinity. That's your end behavior. If it's an even function, you don't have to write it as two separate statements. You can combine them. So again, what this is saying, on the left side, the arrow is going to go down, and on the right side, the arrow is going to go down. Let's look at number 2.
You should only do the same, you just,
Only if it's the same.
plus minus.
Right. So for number 2, 3 is an odd number, which means that the arrows will be opposite. I think only the odd ones are kind of complicated. So I always like to make a little sketch. So is this x cubed positive or negative? Positive. So because it's positive, that tells the right side to go up. The left side is not going to do the same though. It's going to go down.
On the left side.
So when you write your end behavior, you're going to say, as x approaches negative infinity, f of x is going to go down. That's how you say that. On the left side, the arrow goes down. On the right side, now because they're not doing the same thing, I have to write them as separate statements. On the right side, as x approaches positive infinity, f of x is going to go up. And that would be your end behavior. Any questions about that?
Why is it 2?
Because they're opposite. We can't combine them because they're not doing the same thing. And for this one, I mean, maybe I shouldn't have combined them because I don't want people to get confused, but you can write them separate also. I mean, you don't have to combine them. So maybe, so as you see, I just rewrote it as two separate statements. And you all are helping me think this through when I teach 6th period and 7th period. Maybe I won't combine them because I don't want you all to get confused. But just know that for even, because both sides are doing the same thing, we can combine them and write it as one statement. Yes.
So if the leading coefficient were like positive or negative, if it's positive, then it's always going to the right side. If it would-
Right, yep. So here, going back to what you just cut out, because it was odd, we had an odd positive. We had an odd degree and a positive leading coefficient. Looking at the cutout, this is my end behavior statement. All right, let's go ahead and copy down these next one. Now we're going to answer a lot of questions. So I'll give you a minute to copy down these two, and then we'll talk about it. So, yep, in the homework, you just have to answer a lot of questions about the function.
Are we inside of the?
Yep.
Spell discombobulated right now.
You.
So we can kind of talk through them together. What is the degree for A? What's your highest exponent? 4, which is even. So I should know that my end behavior is going to be the same. The leading coefficient is the number in front. Again, I'm only looking at this for the first two. My leading coefficient is 5, which is positive. My constant, that's the only term that's not multiplied. And the constant in the y-intercept, that's asking the same question. So your y-intercept and your constant. So now let's write our end behavior. What do you think the arrows are going to do? Are they both going to go up or are they both going to go down?
They're gonna go up.
They're both going to go up. So I'm going to write it as separate statements, but if you want to write it as one like I showed you previously, you can. So the left side is going to go up. And the right side is going to go up. Because they're even, it's doing the same thing on the end. For question B,
For that one, when you like combine them, you do like the plus minus. Would it just be x plus minus infinity? Then
x as x approaches positive and negative infinity, f of x approaches positive infinity.
So for the first bit, like the x, negative, like positive, those will always stay the same.
Yeah. Yeah. So if you go back, if you look at what you glued down, you'll notice that they all start the same with our end behavior. X approaches negative, x approach, like they all start the same. What's different is the end behavior, which is the y values. All right. So for number, I'm sorry. Yes.
I was just gonna say, and then it's like the left and the right, whatever.
Right. All right. So for this second one, our degree is 5, which is odd. And my leading coefficient is a -2. So let's pause right there. Let's talk about end behavior. So what is the right side going to do? The right side is controlled by the leading coefficient. So over here, what is my arrow going to do on this side?
go down.
On this side, which is the right, is going to go down because this number is negative. This side, which is the right, is going to go down. Because it's odd, the left side is not going to do the same. It's going to do the opposite. Okay, so I'm going to write my end behavior and come back. So on the left side, as x approaches negative infinity, your y value is positive. And on the right side, as x approaches positive infinity, your y value is negative. And then what is my constant in my y-intercept? -4. Yep. Okay, so we did lose a lot of time, so we got to keep moving, y'all. Sorry, because we got to get to a certain point today. So the next thing we're going to talk about, and then we'll end here, is writing your equations. Okay, so that's a big part of this next test. Test, quiz, whatever you want to call it. So this is examples. I tried to pull, this is from homework 11. This is number 44 and 47. They're not the same questions, but they're like that. So I want you to write a polynomial function with the given degree. So I'm gonna give you a minute to copy that down. And for these two, we're going to write it in standard form, which means we have to multiply it. So okay. In order for you to have a 0 at -1, what do you think my factor is going to be? For me to get a -1, what's my factor? So if you have, let's talk about it. If you have x plus 1 and you solve it, do you see how you get x equals -1?
Yeah.
So your factor is always the opposite sign. So when you're writing it as a factor, it's always going to be the opposite sign. So for the -1, write a factor of x plus 1. For positive 1, my factor will be x minus 1. And for positive 3, what's my factor? X minus 3. Now we need to multiply these together. Now, hopefully you know what this is going to equal without making a box, because that's the difference of squares. But if you don't, you can make a box. I won't be making a box, but you can. So feel free, because this is what, feel free to multiply that out to see what you get. Does anyone know the pattern though, or know what it's going to be without multiplying it in the box? Save yourself some time. If not, go ahead and fill in your 4 squares. All right, when you do that, you should get x squared minus 1. So now we need to take that answer and multiply it by the third factor. So I will make a box for this one because I think it might help people. But so let's make our box. And then go ahead and fill in your squares. So that would be x to the third, negative 3x squared, minus 1x, and plus 3. So your equation in standard form, and this is for a polynomial that has these 3 zeros, that would be your equation in standard form.
So the x squared minus 1 stays in a bracket after we multiply them?
So you have to do, it's a 2-step multiplication process. First you multiply x plus 1 times x minus 1, and then you take that answer and multiply it by x minus 3. Yes.
-1 and -3x squared, like terms, we add those together.
No, they have different exponents.
Not if they were like terms.
Yeah, if they were, yes, we would add them together. All right, let's look at B, and then we'll end there. But I will have you all copy down the next question, though. So here we have a 0 at -5. So what would be my factor? X plus 5. Now, when you have a 0 at 0, that's just an X. Like, there is no such thing as X plus. Like, nobody goes to the bank and stands in line and says, I would like to withdraw $0. Or I would like to make a deposit of $0. It's 0, we don't need to have a factor for that. It's just the factor is X. X all by itself. And then for 6, what would be my factor?
X minus 6.
Yeah, and it does not matter which way you decide to multiply these together. Okay, Like, you don't have to start, but I think the easiest way to start it would be to distribute and then take your answer and multiply it by x minus 6. So I think starting off by multiplying x plus 5 times x, and then you want to take that answer and multiply it by x minus 6. So go ahead and fill in all 4 squares.
Ms. Bryant?
Mm-hmm.
So can you, you know how you always tell us like go for like the highest degree? And usually like the highest one is the first.
Yeah. Mm-hmm.
So would there be a time where like the degree is like higher in a different area except the first?
It could be a trick question like that on the test,
But would it still be like?
but it's still the highest degree, even if it's not first. It's still the highest degree. So for this one, Daniel, do you notice how we actually do have like terms? So now we will add these together. So we're going to add these two together. And my final answer would be y equals x to the third minus x squared minus 30x. All right, I'm going to have you write down tomorrow's questions so that we can just get right to it. So before you pack up, just copy down the questions for tomorrow, and then that way we can just get to it.